Hey everyone, welcome back to day 2 of Toronto workshop on reproducibility. Our first presenter is Julien Chiquet from University of Paris. He's going to talk about Computo, which is a journal of the French Statistical Society, which promotes reproducibility. So thank you very much for joining us, Julien.
Okay, so thank you for the introduction, and I'm really happy to present this newborn academic journal. So I am the chief editor of this journal, actually. And it's funny because the first guy who submitted to Computo, he told me about the Toronto workshop, and that's how I heard about you, actually. So indeed, this is a journal which is supported by the French Statistical Society. When I say support, it's rather encouragement than true material support, actually. So we launched this journal at the end of last year, and we decided to make the question of reproducibility central to this journal, and I'll try to explain you how we are doing that. And you can see that there is a web page here at the bottom of the screen, and basically this is the journal, and submissions are open, so if you want to contribute, we will be very happy for this. Okay. Up. Sorry. So I don't know exactly what is the background of the audience here, but I just want to recall some basic facts, at least in my community, that is statistics and machine learning, and about publication in this community, which somehow motivated this journal, actually. So one important point is the multiplication of academic journal and article, and sometimes you don't even have the time to read everything that you wanted to read, and even as a reviewer in some kind of situation, you don't have time to check all the proof and everything. So to my opinion, at some point, it's at the expense of the quality of science. So I think this is really a problem. So when I think about great conferences like NeurIPS and ICML, we have so many papers to read, and we don't have time to check everything. So it's indeed a problem, to my opinion. Even if things are getting better, I still think that there is a lack of encouragement and valorization of everything around numerical thing and computer thing around machine learning and statistical works. So I think it's also a problem. And the few solutions that exist, actually, they are almost saturated. But the nice thing is that we have many great tools which are popping out, actually, like you probably know RStudio, which is a great API to work with R, but not only. You can work with many other kind of languages, VS Code. We have very, very nice now scientific publishing system, like Jupyter, of course, with Jupyter notebooks, but this more recent initiative, Quarto, is very interesting, and we use this actually in Computo to process everything. And we have also all these things around the possibility of making action with Git repository, and especially on GitHub, which provide us with very nice tool to go for reproducibility, actually. And the positioning actually of the Computo's board is to try to renew the way and the mode we are publishing science based on this fact, and I will explain you how. Of course, I want to say a few words about the existing solution in my community. You, of course, have the standard academic journal, like you probably know Statistics and Computing, Computational Statistics, Data Analysis, and so on, GRSSB, GMLR, etc. So these are very important journals, of course, but the way that they publish science, that is basically with a format which is fixed with a PDF, is somewhat limiting the reproducibility, to our opinion. there is also many journals. There are also many journals which are trying to promote some software, like our journal, JOS, so Journal of Open Source Software, GMLR Open Source Software, etc. But basically, there are many submissions to this. Sometimes they are somewhat centered around a specific language, like either Python or R or Julia. I don't care in what language you are writing your code. I just want to make reproducible science, basically. And sometimes they just present some documentation associated to a given package or software. And we still want to have a journal which is speaking about a scientific question in statistics and machine learning. Okay. Yeah. So just to give a few clues about what Computo is in 3 points. So the scope is basically to promote some new contribution, but really some methodological contribution in statistics and in machine learning. That is, we want to publish some work which are centered around a new statistical question and new methodology. And even if people want to make some numerical illustration related to some theoretical guarantee, for instance, Computo should be able to consider this kind of work. Of course, we have the usual prerequisites like open science and reproducibility. That is, we want that everything which is numerical to be reproducible, basically. This is a necessary condition for publishing in Computo. Of course, all the data should be available. And the reviews are open. We can publish the review in an anonymous way, but we want to make public the discussion between the author and the reviewer. And an important point is that we ask the author to manage the reproducibility, basically. So all the process which end up with a work which is reproducible. So it's a lot of work for the author, but we hope it's going to pay at some point. Yeah, so just to present you quickly the board. So we have two persons coming from more the machine learning community and the Python community. So Chloé Agathe Azencott and Nel Varocco. And Pierre Neuvial and myself, we are more coming from the statistical community, but it doesn't mean a lot. Basically, there is not much differences between statistics and machine learning nowadays. So how does it work? Basically, I want to describe here the various ingredients that we use to make this reproducibility process possible. So the first very important ingredient is to rely on notebook systems. So we have very nice notebook systems which are available nowadays, like Jupyter and R Markdown, for instance. And basically, we are using a newborn, which is hopefully reconciliating both of the system. So Quarto is a newborn where you can do some R thing or some Python thing, either in a Jupyter or R ways. So it's very nice to have that because we can include both communities into the process. And of course, a notebooks is the best place to put together what is, to our opinion, statistical contribution. That is some mathematics, of course, to describe the model or the methodology, some code to prove at some points the mathematics applied to some particular problem. And the code can be in Python, Julia, or R, for instance. And you can even mix this thing together if you want. Of course, you have to rely on some existing work. So the bibliography is and the references are very important. So we use the BibTeX system. And the idea is to publish everything not in a PDF, but with HTML document, so that we can use widgets and CSS to have something which can be at some point dynamic if we want. Okay, so the second ingredient is to rely on some Git repository and all the services that come with like GitHub or GitLab thing around the action that you can trigger when you push something on a given repository. So in particular, we have these three components in a GitHub repository: continuous integration, which is very helpful if you want to launch some reproducibility script associated to your notebook. You can also deal with project management, and this is going to be the way that we deal with the submission on Computo and the way we are publishing the finally evaluated contribution. And of course, we can use issues to publish the reviewing and to continue discussion with the reader and between the reader and the author. So, of course, we need to reproduce and to run everything on a computer at some point. And to do that, we use a container service, and we choose to use the binder container service, which is really easy to customize actually, and which is easy to interface with a GitHub repository. And basically what is interesting with binder is that it's going to prove that the notebook can be compiled, basically can be run. So you prove that your paper is reproducible like that, but also you have access to an environment where the reader can reproduce and change a bit and play with the numerical illustration of a given contribution, for instance. And of course, we need a reviewing system. So we use a standard system to do that, but we choose to use a very lightweight system, which is called Scholastica, just to perform the exchanges between the editorial board, the reviewer, and the author, basically. And when the reviewing process is done, we publish everything as issues on GitHub, eventually with an anonymous reviewer. Okay. So this is the theory. So now how practically we can do that. So from the point of view of the author, you have a certain step to do to submit to Computo, basically. The first thing to do is to set up a given GitHub repository. And to do that, you can use, yes, it's working. So you can use one of our templates. Actually, we have a template for Jupyter, for R Markdown, but also for Quarto. And you start by cloning this thing, and then you can start writing your contribution as usual. That is, you write a notebook and you compile on your side the notebook to check that everything is working. So it's really in the same spirit as Jupyter or R Markdown, except that, of course, we want not only code, but also mathematics, bibliography, etc. So this is still the longer step for the author, writing something interesting. In fact. Once you're done with writing your contribution, basically there is a small file to configure in order that your binder environment is configured so that it has the appropriate software to compile your notebook. So for instance, this environment.yaml is defining the different packages and modules that you need for a given notebook. So here I put some example using Conda and some usual packages for Python and for R, for instance. Okay, so you can see here in my repository that I have the contents of my notebook, which is .qmd for Quarto Markdown. and you have various configuration file actually for part of them is the environment file. Okay. And then at some point, when you commit a new thing on your repository, when you push something, it's going to trigger a GitHub action, which is basically doing in a very simplified way here this three thing. That is when I'm pushing on the main branch, but actually I'm installing a container, an Ubuntu container with a Conda environment with the dependency defined by my environment file. Then I'm rendering everything with Quarto, and then I'm deploying everything on a GitHub page. So here, what's going on? It's when you push, actually, it's launching an action here, and if it is successful, you have your GitHub page, and this is your contribution basically. So this is just a template here, but you can write science this way, and at the end of the day, you are just going to save this as PDF in order to submit this to our reviewing system and for the reviewer do their job basically. Okay. And yeah, so that's it. At the end of the day, you have an HTML version on a GitHub page. You produce a PDF. If you want, you can have a binder associated to this, and you submit everything to Scholastica. Okay, so we have some nice, hopefully nice pictures to explain everything in a more compact way, but basically you have three ways to make a contribution with three different templates, but it's maybe at the end of the day, we are going to use only Quarto because it's really doing the best of these two worlds, R Markdown and Jupyter. And it's not so hard to do that. And we already have, in fact, a couple of submissions that works, and people seems to be happy with that. From the editor point of view, once the reviewing process has ended, we basically copy the author repository. We format this with, as usual, I mean, with any kind of journal with our own templates. We publish the reviews as issue, and we add a new entry to our journal website, basically, where we refer the GitHub repository, the data, the reviewing, and so on. And so we developed, in fact, an example for that by reproducing a well-known paper in our community. So here I'm on the Computo website. So if I go to the article page, we have this mock contribution, which is a redo, in fact, of a paper which is known as TSNE. So it's a method for performing dimension reduction, actually, which is very popular in many fields of application, and which is at the crossroad, basically, of statistics and machine learning. And so the idea here is just to make an example to show how does it work. So we have, of course, an abstract. We have a GitHub repository. We started this from the template, in fact, and it works exactly the same. We have the content of the contribution. We have some file for setting up everything. And this is published on a GitHub page. And for instance, here, it's a more advanced thing, but it can be reproduced whenever we want. And we can launch this binder thing if we want to execute this notebook in the same environment that it has been built, basically. Yeah, so for instance, we have some code at some point. Here, for instance, you can include some fancy algorithmic formatting if you want. Yeah, here we have some Python, and that's it, basically. Okay. I've lost my original slides. Where are they? Okay. And yeah, so this is the full process. So maybe it's a bit technical, but it's the full process, including the editor point of view. But basically, the author is preparing his submission, and we are looping as usual at this stage if we need to many round of reviews or not. And at the end of the day, we publish that thing. Okay, and I just want to say a couple of words about some very nice initiatives that, in fact, inspired us when we created Computo. So DISTI is a very nice initiative, but this is essentially centered around deep learning and machine learning thing. And moreover, it's the way the publishing is made is a bit complex, to my opinion. Rescience is also a nice initiative, which is publishing some remake of some existing work, but to prove that they are indeed reproducible or not. Okay, so sometimes you don't find the same thing that the original paper has been publishing, in fact. And this initiative is also very nice. The peer community it has developed a lot in France, but unfortunately not yet abroad. So it's a free recommendation process where the people are trying to build a large community of recommenders and to recommend preprints, in fact. And basically, we plan to create a PCI for Computo to bypass Scholastica and to directly have the reviewing process done completely openly, basically. Okay, and just a word about the logo of Computo. So it's a very nerdy thing, which has been suggested by Loïc Schweller, which is who was, sorry, a PhD student in your lab, and it's basically a binary writing of Computo, and that's how you are ending with this logo that you have here. So I'm done, and thank you for your attention.
Thank you very much. This is so exciting. Does anyone have any questions or comments? Nick, did you have a one?
I mean, it's more of a comment than a question. I mean, you know, it's great. I love the look of it, despite the fact I was snarking about the fact I don't like the way you formatted BibTeX. I think that's very non-standard. But no, it looks great. And you know, I was just talking to people yesterday about it's such a nonsense that for so many years we've let the publishers have these paywalls where, you know, the academics do all the work, they do all the reviewing, they write the papers, they get charged to put their stuff in if they want it for open access. And so it's so great as well to see it as, you know, not only reproducible, which is obviously the thing that we're focused on here, but also just genuinely opening up science and so forth. I suppose if I have a question, it would be, this is obviously very appropriate and suitable for the kind of audience you've got, an ML type audience. But I guess in principle, we'd like this to spread, you know, across the sciences and across, you know, the social sciences and all research and so on. And I guess I was just thinking about, you know, when you start talking about Binder and, you know, packaging up your software and all that stuff, how that would work for, you know,
so that
sociology or something, but.
Yeah, so it's a good question. And actually the people from the peer community where it's developed in various fields of science, among which more social science, for instance, they were really interested in including the Computo way in all these communities. And of course, to do that, we need some, basically some engineers that are going to automatize everything. But I guess that from a simple markdown thing, it will be possible to completely automatize the process. If you don't have complicated math and software thing, I mean, we have the tools nowadays to do that, I hope. So the people from various fields of science basically just need some help from us, but I think it will be very nice to do that.
And I suppose I was also interested, I mean, did I understand correctly that the version of the paper that gets produced is produced on the site using the system rather. So in that sense, it has reproduced by the time it gets published.
Yeah, exactly. So yeah, when you push your commit, so you change something on your article, it triggers an action, and everything is compiled, and the code is run actually. So yeah, you really reproduce all the results that you pretend to have in your paper actually. And of course, if you have some very complicated deep learning thing which need to run for months, the idea is to save some binaries at some point and just to reproduce a toy example to show that at the end of the day you are able to get this kind of results. But of course, we ask for the binaries to be published too.
How much work is this taking of your? Is this all you're doing, Julien, at the moment?
No. I'm not doing just that. I don't know. It has been a lot of work actually to put everything together, the website, the tools, and everything. But it's okay. I think it's important for the community to do that. I'm at a stage of my career where I think it's nice to do this kind of thing, but I'm not at full time on this actually. But I guess that the more complicated part is behind me actually, because we have this thing which is working, and hopefully if we have some people who can work with us on this, it's going to be more easy in the future.
Can you comment?
But now, basically, we need some submission now. So we need people to write something, and we are happy to help, of course.
The open reviewing aspect, I love. So I did this for one review for Harvard. Data Science Review has taken this approach as well.
Okay.
Could you talk a little bit about how folks have found that?
So basically, when we do that, reviewer that really takes the time to exchange with the author, and more than that, we hope that once the paper is published, some discussion and some exchanges are going to continue basically from the readers. But there is clearly a question of whether we should put the reviewer name public or not. So that's why we let the choice basically to the reviewer to do that.
Yeah, that's the approach they've taken also. You get the option.
Yeah.
Right. So maybe we can just put the link in to the chat once again. So folks, if they have some submissions to the journals, they know where to go. Computo. And it's really statistics and machine learning.
Yeah.
Targeting.
But actually, we are contacted by people from more public statistics thing, and they were also very interested in this kind of thing. It's more it's less methodological, but the way we want to make things reproducible and everything, they were clearly interested in that actually.
Very good. Thank you very much for your presentation, Julien.
Yeah, and if you want, I also have the slides which are available online. So just put the link very quickly.
That'd be excellent. Thank you. Thank you.
Right here.
Well, hopefully we can hear from you next year, and you can tell us all about your first few issues.
Yeah, I'll be happy to do that.
Thanks very much.
Thank you.